Good morning, good evening, and good afternoon, everyone. Thank you very much for attending this TRB and also the ECTRI special session on innovations in transit. So my name is Peter Chen. I'm a senior transportation planner at the Santa Clara Valley Transportation Authority. So as a member of several TRB committees, well, actually, including the public transportation planning and the development, bus transit assistance, and also the transit research analysis committees. I am honored to help to organize this TRB special session. We also are very grateful to have the support from the ECTRI. So ECTRI is the European Conference of Transport Research Institutes. Especially, I want to thank the Caroline Amaras, Secretary General of ECTRI, for letting the TRB and the ECTRI's cooperation happen. And we are delighted to invite 4 distinguished speakers to join this session. So you can see we have 4 speakers here. And I think it will save the time. So I just, let's start the first speaker. So first speaker is the Dr. Guowei Tong. So Guowei joined the US DOT Federal Transit Administration, FTA, in 2014 as the Director for Mobility Innovation in the Office of Research, Demonstration, and Innovation. As Office Director, he managed the FTA Mobility Research portfolio that includes the Strategic Transit Automation Research STAR program, which he will present to us shortly. Prior to joining FTA, Guowei was a private sector consultant focusing on ITS project planning and assistance engineering for public transportation. Guowei is also a University of Michigan alumnus. So Guowei, that's yours. Thank you.
Thank you, Peter. Thanks for having me today. I'm going to need your help to see if you can see my screen. Just give me. All right, so, okay, I'm going to stop yours and.
Yes.
Can you folks see mine?
Let me.
Oh, no.
Not yet.
Not yet?
Peter, you need to stop sharing so that we can.
So how? Wait. So how I can? Oh, stop sharing. Okay, sorry.
No, it's
okay. I just stopped sharing.
So folks can see my screen now.
not yet.
Yeah. Still no.
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 So what do you see? You just see me? You seeing anything on the screen?
Yeah,
see.
We only see you.
See me? Let's see. Toggle subtitle. No. Let me share. Let me try to share again. I'm going to say, I'm actually a little confused myself. Share screen.
So
share.
I could, okay, you got that? Great. Mary sent us the slides a couple of days ago, so Bala may have those as well.
That's a good idea. So you guys still not seeing anything?
Oh, yes.
It's good?
Yeah, good. Yeah.
Okay, cool. Hello, I'm going to go by Happy Wednesday. I think that apply probably most of our list, the time zone. So I'm going to share with you about
So we are not able to hear you. You are muted now.
And looks like the screen share disappeared too.
Hi, Guowei, you are muted.
Oh, I'm unmuting.
Yeah.
Good.
Also, you stopped the screen sharing. Just share the screen again.
Stop the screen sharing.
Oh,
right.
it stopped. We can't see it now.
So Corey, do you want me to share the screen to show your slides?
Okay, let me see. How about this?
Oh, okay. Yeah, we got it. Thank you.
Okay. As you can tell, I'm Zoom challenged. It's probably explained because the DOT we use Team. All right, so hopefully I'm going to just leave it, and hopefully we can. Let me see if I can change between slide. You guys can still hear me, right?
Yes.
Okay, good. So I'm just going to leave it like this. All right. Thanks for having me. And I'm going to say happy Wednesday. Hopefully that applies to most of us now. And so today, basically here to share with you all FTA research in general, in particular mobility innovation related. That's the office that I am part of. So first, I want to share with you a list of challenges. So we probably really have more than this, but this is just a attempt to kind of categorize what are the challenges that public transportation, especially from the operations side, face today. And hopefully a number of you who are from the operator side can resonate with those. And one, I'm going to go from the left to the right, and the fiscal cliff. This is a known issue, has been a while. Because during COVID, we have this emergency fund for transit agency that face frontline worker issues, and as well as the ridership drop. And a lot of agencies go fare free to try to be helpful to mitigate the exposure. So all these factors together, we have this emergency fund that to sustain public transportation services across all communities. And now this funding is coming to an end, and so a number of transit agencies, especially the large urban ones, are facing what we call fiscal cliff. And the safety for both operators and riders, a number of transit agencies, and a growing number actually, are facing homelessness and mental health issues that occur in our transit properties, and so onboard transit vehicles that become more of urgent issues that we want to find a solution for. And the accessibility, the transit desert, that we have known this, and the climate issues, and low emission transit fleet transitions. I'm moving kind of quick. And then changing landscape, the way that we move from to meet our mobility needs, and also how we actually meet those mobility needs with the addition of a virtual being in some cases a viable option to meet mobility needs like we're doing here, even though, again, I'm a Zoom challenge. But the fact that we can actually carry out this conversation across different places, that in itself highlights the changing mobility pattern, that including impact on transit operations and ridership. And the workforce. Workforce is definitely an issue that has always been an issue. And I think COVID-19 kind of like exacerbated and make it to the front line. That is something that we really need to, not just the short term, but to find us long-term sustainable solutions. Now, to all those challenges that we just talked about, what transit actually doing, what FTA is doing, and the way those are just a list of things, the kind of topic areas that we are interested, either has been invested in, or we will kind of taking a closer look. Overall, the way that we look at mobility innovation research at FTA is, sometimes I will use the analogy of a college, and consider that this is a four-year college, and our research office, I consider ourselves wearing the hat of being an admission office. Like, we will continue to look at what's possible to explore new opportunities, just like the universities that we will go out to find what are the potential prospect students that will bring value to the student body itself, also to the university as a community. And we do that, we can consider that and looking at what are the students, or what are the research ideas we want to bring into our research pipeline. And on the other spectrum, in the senior class, we also put emphasis on how do we actually make sure that the research outcomes and results that we learn throughout this process, the graduate student actually get a job placement and make a substantial contribution to our society. Same thing for research. research that through the pipeline that the incoming student from the freshman class all the way through senior class, and certain project or certain technology capabilities or partnership and models that we consider somewhat proven. We do want to promote wide scale deployment so we can really benefit from the research what we learn. And so we put emphasis on that, and we have those things in between. And then we also have topics, and I'm going to pick the one on the top, like transit automation. This is one of the examples that sometimes I kind of just jokingly and within ourselves said, oh, transit automation is kind of like a PhD student because they stay there for a long time. And I think transit automation is one example. It's not going to graduate for within 4 years. It's going to take a long time, like PhD students. Another part that I also wanted to share with you all, by using this 4-year college, I think it's very important for us to always maintain a healthy pipeline in terms of like we have a healthy body of freshman class, each class, right? Freshman, sophomore, junior, senior, and that pipeline should remain healthy at all time. And certain topics we want to look at because they are urgent issues that we have to find a solution quickly. We need to invest our research to that. And also equally important that we have to look at what's possible. That's not necessarily it's a problem driven per se, but it's opportunities that we show earlier. Like what are the opportunities, the potentials, what's possible for public transportation? We want to look at those too. And then understanding that some of the very the student that we have met in the freshman class, it looks have a great potential, knowing that some of them will drop out, which by virtue, I said, wow, that's kind of the research is. Like we were thinking, like we were admitting some of the very promising ideas may turn out not to be the case, which is okay as well. So for the remainder of the presentation, I want to share I'm just going to pick the PhD students, the transit automation, to take a deeper dive. And in our mobility innovation research, we actually do a spectrum. Right now, we look at transportation insecurity, and we look at transit automation, and we also have a new program like Mobility Next that really look at the emerging technology capability, what's possible for public transportation. So again, I just want to use transit automation as an example to share with you what we have learned and how we see this PhD student in our mobility research pipeline. So why are we doing transit automation? That we do see a great potential that mobility experience will be enhanced through this automation capabilities. And we want to promote innovation and transformation, enhance safety and operations. One thing I want to share with you is I've been in transit industry just like many of you for a while, and we realized that transit is a relatively risk-averse industry, and for good reasons. And in many ways, I think we should be. Now, so when transit industry face new capability or technology that may look really great or really exciting, and transit reaction to that is typically very reserved. And I used to say that transit agency, when you have something like shining tools and kind of dangling in front of agencies, and who wants to be the first to try? And everybody look at it as, I don't want to be the first, but I'm happy to be the second. And transit automation is one of those examples that transit agencies, many of them, see a great potential being one capability in our toolbox, which in some ways is kind of unusual, and also give FTA a level of comfort, knowing that if transit agencies see a good value in certain technologies, that probably in itself means it's a good potential. It's not just we don't invest something just because it's cool. Now, where we are today, it's not commercialized. We all know that. And one thing, if I may add to that, is it actually takes a lot longer, not just for transit automation, for any vehicle automation. We realize that when you look back, like what, 5-6 years ago, when people start getting excited about automated vehicle, what it was projected out in 5 years, we're nowhere near that. And same thing for transit automation. The things that I do want to note is transit industry remain very interested in this space. Like I said, in itself, it means a lot, and in terms of informing our research investment. So the pilot demonstration underway, and the third bullet is really speaking of, in addition to technology, when we talk about transit automation, especially put the capability in use in the field for revenue service. It not just involve technology, it involve a lot of the policy, rules, regulation requirement, which FTA or federal government or any government in general have plenty of. So how those rules and regulation requirement actually apply when it comes to automation, in this case, transit automation, it requires a lot of clarity, and it we know that requires certain level of modernization. So we need to invest in that as part of the research. So to react to this transit industry need and desire to have FTA take a role, invest in transit automation, we launched this program called Strategic Transit Automation Research, very conveniently have a name called STAR. We published this 5-year STAR plan. They broke down the research area into 4 buckets: enabling research, human factors, accessibility as examples, the light duty vehicle automation transferability. Those will be considered examples of enabling research. And then we do integrated demonstration in the sense that we wanted to have a closer look of certain use cases that make sense to transit. And by that, I want to say is one thing that we really kind of focus on as part of the STAR plan is, like I said earlier, transit agency not interested in transit automation just because it's cool, because transit industry wanted to try to learn from automation because it actually present a potential and solve certain challenges that we face. And one of the example was the maintenance in yard operations. And the reason why it triggers that was, a number of transit agents say, well, we have a certain size in the urban areas that this is our yard, and we have a growing size of a transit fleet. So how can we optimize or maximize the use of space that we can still effectively maneuver our fleet in the end of each day when all the buses pulling back to do the washing, charging, filling, all this work, and then park. So is it automation present a opportunity for us to make a better use of the space, the limited space that we have? This is one example of a use case driven demonstration that's in our STAR program. Strategic partnership is a way that we recognize, well, there's a lot of transit agencies that doesn't really need or want FTA invest or federal investment. And a lot of the local jurisdiction, the state, they say, well, we're going to invest our own resources to learn from this automation. And from FTA standpoint, that well, we actually have a lot to learn from those projects as well, not just limited to the project that we fund. So the strategic partnership was meant to be like, we want to partner with project sponsors that we don't directly fund the demonstration, but we see a potential to learn from it. And then we will add additional funding to perhaps collect additional data and evaluate the result, that kind of thing that's considered strategic partnership. And obvious stakeholder engagement should always be ongoing. And this is one map that, I'm sorry, Peter, do I have like 5 more minutes, or can you give me like 5 minutes? 5 more minutes?
Yeah, 5 more minutes is
Okay,
fine.
I will try to
Thank
wrap up. Thank you. So this is one kind of effort that we consider as part of the STAR plan. It's not so those are the projects that we either directly funded or it's not FTA funded, but it's through other modes or US DOT funded that we manage. And I can see the location. And I want to take the opportunity of this map and also broadcast for those of you who are interested in transit automation research within the US. FTA actually put up a quarterly update that we're really looking into all the deployment, pilot, anything to that effect, not just limited to FTA or US DOT funded or any project that we can, any effort relates to transit automation that we can the information that we can collect, we include them. So if you are not aware, I think that in itself is a good source of information. And the way that I get that, I would just say that just go ask Dr. Google, say FTA star. You should see that quarterly report. We religiously update that report every quarter. So if you want to get a snapshot of what's going on throughout the country, and that's a place for that. And then this just and the way that we define our transit automation research, and we look at all spectrum of level of automation. We look at all size of vehicle platforms. We look at different use cases under different operator design domain. So in this case, we look at a full-size bus, we look at cutaway bus, and we also look at potentially leverage light-duty vehicle, automated light-duty vehicles for public transportation purposes. So ADAS is one area, and then earlier that I mentioned about the bus maintenance yard that we recently selected 2 transit agencies to work with, and they will be experimenting, introducing automation capabilities in their maintenance yard. So in this particular case, it's not really a revenue service, but it is actually exploring the potential to alleviate a challenge that transit agency face. So 2018, we developed this plan. It was a 5-year plan. Now we are 5 years, and we're in the process of updating that plan. And so hopefully towards the end of the year, we will have the next 5-year plan released. So we look at those factors and consider source of input. And this is, again, it's the website. Instead of you will have this slide, I assume. If you don't, just go to FTA star. You will get to this, and a lot of the emerging technology research reports are there. Every demonstration that we will actually go into independent evaluation, all the metrics, quantitative, qualitative. Once the project is concluded, we will publish those results, and you can get those results there as well. And with that, I would turn the floor back to you, Peter. Thank you for your attention and time.
Well, thank you very much, Guo's presentation. And I believe everyone has more impression about what the FTA's STAR program. And I'd like to know if anyone have any question for the Guo. Well, so may I have a question for Guo now? So based on the like a 5-year the STAR program, so how this like the transit automation be consistent with like the general vehicle, like the electric vehicle or the autonomous vehicle? So will the transit side and the auto side be kind of the same progress, or any like a cooperation between kind of both the industry?
Thank you, Peter, for the question. We actually look at this from at least two angles. I just immediately think of 2 things. One is earlier that I mentioned the way that we define transit automation. It's not limited, even though we say focus on transit buses, but that buses is probably different from the most people's mind, like, oh, buses are those 40-foot or articulated bus. No, we actually define bus being any motorized vehicles that can serve share ride purpose that potentially include, or that does include, light duty vehicles. And so in many ways, it's not really how the vehicle look or the size of the vehicle, but rather what does it do. And so one of the research that we invested in was Arlington in Texas. So that one is, we did not really invest in, even though we collect data, we did not invest in the actual development of the technology. That was a technology that already available in the light duty, on a light duty vehicle platform. And so we kind of use that vehicle to provide, to experiment that with incorporation into microtransit purpose service in Arlington. And I believe that report has been published. Now, the other side that we look at this is what can we learn from light duty vehicle? And is any advancement being made in the light light duty vehicle side can be readily applied to transit buses. That's another report that are available. We see some very limited cases, and a lot of times that because the behavior of transit buses or the need of transit buses, the operational characteristics, it does really. Most of the light duty vehicle advancement that we can benefit some to a degree, but not a whole lot. So we take a closer look at that. We will continue to monitor that. So to your point, anything that we can do and without recreating wheel, we definitely will be for that. And then while we're doing that, any advancement that already made in the light duty vehicle side, and public transit, we want to take advantage of that as well. That means the light duty vehicle side. So that's what I will. That's our approach.
Oh, thank you. Thank you, Guowei. Oh,
Sure.
Okay, so the Casey Emoto from VTA has a question. So if there's one thing that we could expect from transit automation, what is it?
Is that the one thing you can expect? I'm happy to share. It's a long journey. It will be a long journey. And then I think one thing that we also want to highlight is workforce is an issue, and then a lot of concern being shared, and we're aware of those things. And I would just say that I personally don't see anytime soon, if not a decade, that we will ever see. Well, depending on the use case, I want to take it back. Depending on the use case, if you want to see a bus on the open road that have no people on board, no operator on board, that will require a lot of not just the technology. Then we have to look at the accessibility. Do we have ability to have automated securement wheelchair of different sizes? And then we also have to address different security issues and onboard safety, which, quite frankly, operators today play all the roles that today. So we need to be able to not just the technology, be able to automate it to do just the driving portion. We have to automate every single function that we rely on our operating perform today. So workforce is an issue, but I don't see that anytime soon that we will ever get to that point when we do the automation and the open road. I think this is one thing that has repeatedly come out. I think there's a lot of dialogue should still need to be had. And transit workforce is nothing else. It's the single most important asset for any transit operations. And transit agency knows that. And the workforce should know that too. So this is something that I think it needs more dialogue, and how do we collectively work together to really fully benefit from the automation capability that can potentially bring to transit industry, and while minimize or mitigate or eliminate any of the potential negativity, something that we will continue to look at. And so it's a long answer, but I think workforce, when you say one thing, workforce just pop up my mind.
Oh, thank you. Because I think because our time is very limited. So let's the question from Melanie Chen. So Melanie asks, there are modular vehicles tested in Dubai, a kind of a transit automation. This is a very flexible transit mode that even can combine with the freight. How does the FTA think about this mode?
I have to say that I'm not, can you explain a little, or maybe we can talk to you, because I'm not exactly, I don't want to answer that. When you say modular, you're talking about those novel design? Automated vehicle?
Well, my understanding about this modular vehicle is like a different part. So this part can be combined and also split for different destinations. So
okay.
I read the paper from the TRB annual meeting. Yeah, I know this modular vehicle or modular transit. Yeah.
It's in a way that's similar, resemble the PRT operational concept. Is that like the platooning and then separating the offline station? Is that, but let me answer this way. I know we are short on time. So one thing that we are exploring that not necessarily, I don't think it fits your modular definition, is the automated BRT. And we do consider that the platooning in a dedicated right-of-way in Connecticut. We are doing that experiment demonstration, and that does include that in terms of concept. It does have that concept that when you electronically couple or decouple, in this case, is traditional buses, and running on BRT and then off route out of the BRT and apply a different set of automation capability when it gets to the mixed traffic. So it conceptually, it's probably a little bit similar, at least, to your modular concept, but it's not a parked car like you may be referring to the PRT type of operations. I hope that answers your question. But if not, please feel free to reach out to me offline.
Thank you.
Okay, great. Thank you, Go's answer, and it's great discussion here. So, well, because I think the time is
Very
really
sorry to
limited. So
interrupt.
let's go to the next speaker and presentation. Thank you, Go.
Thank you. Thank you.
Thank you. And so may I have Dr. Ingrid Skogsmo to present your, Go, could you please stop sharing your slides?
Yes, let me see share stop. Boo. I hope I'm more proficient with pause share.
think
No,
just,
okay. I think I'll just do share
top.
and then I will
I can do
say,
that.
oh, you can do that? That'll be
Yeah.
great.
I have stopped yours.
Oh, cool. Thank you. You saved me.
And it seems I'm sharing, isn't it?
Oh.
Yeah.
Am I sharing? Yes, you see?
Yeah, Ingrid,
Yeah.
please share your, yeah,
It
your
says it says I'm
slides,
it says I'm
please.
sharing.
Yep, we can see
And,
it.
You're fine?
oh yeah, we see that. Yeah.
Yeah.
Let me introduce Ingrid, Dr. Skogsmo first. So Ingrid is a senior research lead for the future mobility at the VTI, the Swedish National Road and Transport Research Institute, and the president of ECTRI. And Ingrid has worked in Sweden, the United States, and the European Commission in Belgium. Her experience, including 25 years in automotive industry in roles such as the director for Volvo Cars Safety Center, manager for safety and environmental strategy in Ford in Dearborn, and the vice president for Cooperative strategy at the Volvo Group headquarters. Ingrid holds a Master of Science from Chalmers University in Sweden, where she was awarded an honorary doctor in 2008. And Ingrid, that's your time. Thank you.
Okay, well, thank you so much, and thanks a lot for inviting ECTRI to this important conference. You may recognize a couple of things from the previous presentation, because I will talk about public transportation and CCAM. And CCAM, I'll shortly get into what that is, and then also talk about how we tackle that in a European way of having a partnership, and then talk about experiences from public transportation with CCAM. So what is CCAM? I'll say that now. It is a cooperative, connected, and automated mobility. We spoke before in the last presentation about automation, but we also would like to, in Europe, we have enlarged the concepts to go beyond automated vehicles, but also to emphasizing the importance of connectivity, and also the possibilities of having the vehicles cooperating and not just thinking about vehicles, but actually the whole mobility arena. So that is CCAM. Just also because we talk about ECTRI here, which I have the honor to be the president. This is a European organization, a conference of the Transport Research Institutes, as Peter said. We have 29 major research organizations in Europe that are members, and they come from 20 European countries. So this means that we have access to over 3,000 research staff that are active in mobility and transport throughout Europe. And the idea is then to, well, ECTRI is there for the members and to help and support in preparing common research projects. With all these researchers, we have the chance to provide excellent expertise and advice to policymakers like the European Commission, but also we are involved in international dialogues like with the TRB, and this is a living example of this, that we participate in this interesting conference here. I would just like to say also, I mentioned TRB. In Europe, we have TRA, the Transport Research Arena. It is much smaller. It's not as huge as the TRB, but nevertheless very interesting, very important. And if you have nothing else planned, I think you should plan to come to Dublin in 2024 to next year to join the European version of the TRB, where we actually welcome a lot of, with great interest, also persons from other continents. Having said all that, we get back to the CCAM here, and so I will talk from the European perspective, because in as also was pointed out by the previous speaker, this is so complex. You have to be many in partnership that address this, and the European Commission has decided that let's see how we can gather all the stakeholders that are interested and important to take advantage of automation and connectivity, and create something where a partnership where we together can strive for European leadership in safe and sustainable road transport through automation. So also, as the previous speaker said, automation is per se not just a cool thing, but it has to be useful for some reason, there for some reason. And the reason we take this on is to provide safe and sustainable road transport, and also strengthen European industry competitiveness. It is a program that has then financial support in part by the European Commission, and it started in June 2021, will go on until 2027. Then we will have a new renewal of it and go all the way to 2030. It connects over 200 partners. It is growing. These partners represent the 6 categories that you can see here. Very important is that the public authorities and road operators, that also was a subject of the previous presentations, are represented here. And industry obviously is important here as well. Industry is not just the auto industry, it's also infrastructure industry, the telco connectivity software side, and it is freight as well as personal transportation that we look into. So yeah, you see the research organizations, obviously, like ECTRI then is one here as well, and individual research institutes also. 26 of the 27 countries in, 26 European countries are involved here, I should say. And one of the big things we do, similar to STAR, we do a strategic research and innovation agenda within this partnership. And it is then used in the cooperation with us, with the European Commission to set out the coming research and innovation programs and to create topics and calls. And in 2021, 2022, there were 11 different themes where there were calls for research funding, corresponding to about $170 million. And 23-24, it's again 11 topics in approximately the same order of magnitude of funding. So it's a great interest from the European Commission and of course from all the partners. Show you one more slide about the CCAM partnership, because I think this is important when, not least when we come to transit. It is that it used to be in the hype time when we started to discuss about such a partnership, that technology was the thing to worry about, to develop sensors and to think about the vehicles. Over time, we have understood that it is very complex, and there are 7 main areas that need to be addressed in order to arrive at what is at the center here. We want to have large-scale demonstrations of large fleets, or even large-scale implementations of automated mobility where it makes sense. And I think that the where it makes sense has grown in importance. So this, you can see that we call that we work in 7 clusters. So people are involved in different clusters here. For example, I lead this societal aspects and people needs cluster, which is then a team of partners that try to figure out what are the societal aspects of connected and automated mobility, and what do people and society really need in order to meet the societal targets and other needs that are out there. So yeah, you see all these different aspects that are treated, and I think this is very important, that it's not just one, it's not just about the vehicles, it's about making this meaningful, addressing technologies, doing validation, integrating the mobility solutions into the entire transport system and the infrastructure, to take advantage of key enabling technologies like AI, machine learning, what not. And then, as I said, with the societal aspects and people needs. And of course, we also need to coordinate all of these 200 plus members and the efforts that we make here. So that is another cluster. And all of this then to arrive at large scale demonstrations. So when we speak about automated mobility, I think these are typical pictures, at least from a couple of years ago, what it looked like, what we had in mind, and what we envisaged. Very nice pictures. And what is the reality like? To get into transit now, I'll give you 2 examples of projects which are reality, what we're trying to do. One is called SHOW, which stands for Shared Automation Operating Models for Worldwide Adoption. It is a huge project in European measures where 69 partners from 13 EU countries work together over 3 years. It will go on until the end of this year, and to do real life urban demonstrators of shared automated mobility solutions in 20 cities. It's about, well, slightly over $30 million that is funded by the EU, and then very much from the partners as well. And these are the locations where automated robotaxis, buses, and shuttles for persons and goods are around. It's different what you have in the different sites here, but some sites have more options, but it's different. It's not that we have said, okay, this is the robotaxi, please deploy in all these sites here, but it's different. It depends from what goes on in the different areas, and that is then brought together in this project. I come from BTR. BTR has its headquarters in the uppermost dot that you see in, well, Linköping, which is Sweden here in the top. And in Linköping, we are running these nice shuttle buses. And we have asked ourselves if we think what we really want to do, we want to have safe, sustainable transport systems for all. And you can ask yourself, do the automated shuttles really play a role here? So that is one question we have. And I think it is a relevant question, because if you look at, we did a benchmark of all shuttle projects that we could find also in the US that were operated up to 2 years ago. And we try to understand why are these shuttles run? Is it just because it's cool, or is there any purpose behind operating shuttles, or is it just a nice research project? And we benchmarked a couple of initiatives then, and we found that typically why would somebody want to have a shuttle in their city, for example? It was public transportation that was the lead idea, that was it, to improve public transportation, to enhance public transportation, to make it more accessible. That was the main purpose. Then also to learn and get experience with the technology was high on the agenda, and less about accessibility and equity that was mentioned by the previous speaker here. But I think it's interesting that it was really public transportation that was the main driver for these shuttles. And it's the same in Linköping, where the project, we call this initiative Ride the Future, and the idea here is to demonstrate how an automated shuttle can be a part of the mobility solutions in a future sustainable city, because where we operate these is a brand new part of Linköping that is built. It's about 200,000 people living in the greater Linköping area. So for Swedish measure, it's quite big, but maybe not in the US sense. So in Europe, we like to talk about living labs, and this is really a living lab. We learn things every day, and this is a collaborative research platform, and not just a public transportation means as well. So there are lots of things that we try to investigate here. And we are 8 partners. You see them listed at the bottom of the page. It includes the city of Linköping as one of the partners that fund this, and the operator as well, the transit operators, and then us as researchers and a couple of other actors here. So should also say the landowner where these buses run are, besides the city of Linköping, is also another landowner here, the one to the left in the row at the bottom, and they are super critical to have on board here. I will show you why. You can also see, if you're familiar with these vehicles, that they are SAE level 4, so they can be automated in not all circumstances, but some. And they are of 2 makes, Easy Mile and Navia. We have the safety driver was the safety operator was pointed out by the previous speaker as well, that you cannot just have them without any people yet. And they are very important. We have a couple of trained drivers that operate on these buses. So they are, we call them safety operators. And we have a route which is 5.5 miles approximately. It goes through this newly built area, which has a couple of challenging communities in it. There is a school for children with special needs. There is an elderly care home with dementia struck persons, and there are also the normal impatient parents and people who need to get to the office. So and a lot of students. We go through a university area here as well. You have information on where the bus shuttles are through apps, and it is connected to the information system about the normal public transportation in the city. When we think about this, and what we are learning is that CCAM for public transportation is not just the bus, it's not just the technology, it's the entire service really. And with service, we think it's important that if you want to implement this in a meaningful way, that we can secure that the purpose of a trip can be reached. If a person is going to the hospital, well, and if you take a taxi, in Sweden at least, the taxi driver may walk you into the hospital reception. So you reach your purpose with the trip. And I think that that is one thing to think about when we think about the workforce also here, that if there is it has to happen, and it may not be on the vehicle. So it is a service, it is a technology, and it is this why would we want to have an automated part of our public transport. As was pointed out by FTA, the business case is really tricky. That is one of the reasons why the public transport operator in the region in Linköping is interested here, because they want to see how can they get rid of the driver in the long run, because that is the way to save money in public transport in Sweden, they think. Where do you deploy? What is the routing? What are the hours when you run? Is it when it is meaningful? And how can you make that equitable? Is it fair to have an app dependency if you want to ride on these things, or if you want to buy tickets, or how does it work? So several of these questions that need to be figured out before this becomes a big reality. And what we have learned also, that was also said before, technology is not at all where we thought it would be 5 years ago. It is super immature, I will show you. And especially for these shuttles, there is a big complaint that they are very slow. They drive about 25 miles per hour. No, 18 miles per hour. And they also cannot really run into anything. So they brake very hard. And you will see here typical things that happen on a typical road. You have leaves and you have sand, and in Sweden you may have snow, and even if it is plowed, you will then have an edge that is quite sharp. The sensors cannot live with this. They don't understand. They get blocked, and they stop super abruptly. And also you can see in the middle picture here that there is a red car cutting in front of the small shuttle, because they are impatient. They think this is far too slow for them to lie behind. And if you do this too abruptly in front of the shuttle, it will just slam the brakes, and the safety operator may fall, or people may fall if they stand as riders. So among the lessons learned is that this hard braking that is there not to run into anything on the outside may actually be not well balanced on the inside with the solutions there. So you may need to ask people to wear seat belts, which may not be what you want to do. Sounds, these vehicles typically have sounds. If you are blind, you have no clue. Are they stopping? Are they opening the door? Are they running into me? There is no standard for these things, and that needs to be there to make it really something that also can serve a community that has a hard time to travel independently today. And to make this also something that is good for those needing mobility aids. Wheelchair mounting, for example, is not possible to do in a safe way today, and these buses at least. So there is a lot to work on still. The technology, as I said, is not there. The service needs to be designed with equal care as the technology, I would say, not least because the business case need to be found. And these are expensive things, and we need to make sure that they somehow can be part of a profitable solution. Otherwise, I doubt the sustainability of this. The purpose must be clear, and the only way to figure all this out, I we believe is to learn by doing and to share the lessons learned. And then the partnerships and events like these are excellent. And then, of course, to interact, involve, and inform everyone, those who are the intended users and riders, to build trust and use. And here, if you want to do this for automation in general, I think public transport is a super excellent tool to do that. So public transport can really play a key role here. And just then to end and summarize, I think the summary is that we have to get, and we are getting from hype to reality, and we understand this is super complex, and public transport can be a key use case to really stress to make the deployment meaningful and helpful. And just to paraphrase, I think we shall not ask how society can accept CCAM, but ask how CCAM can help reaching the societal targets. And if we do that, I think we will be able to also have meaningful automation through transit. Thank you so much for your attention.
Well, sorry. Well, thank you, Ingrid. Give us a so great presentation. And any audience have any questions? Well, actually, I have one question. So, well, the CCAM will actually give us the many, maybe let's say improve the equity or improve the accessibility, or it become the more convenient. So how about from the passenger perspective? Like, is there any cost evaluation, like before and after, like a traditional public transit and the transit with the CCAM, how the cost will change, like
for the users?
Yeah, for the users, yes.
Yes, the thing is that this is not so well implemented yet. There are some implementations in Europe where you have to pay now for these kinds of, well, if you take shuttle services, I don't think it has been evaluated yet, but most of the pilots and the demos and things like this one that I just outlined from Linköping, these are actually free, because it's we don't promise anything. We don't have timetables and that are a part of the commitment of a public transport operator, and that where they will pay fines if you are delayed and things like that. So they are free rides. In some cases, there is if you buy a public transportation ticket for whatever bus in a city, you also have access to the shuttle. So and I know in some areas they have made public transport free at all, so then it's not an issue. So I think it is a tricky one, and sometimes when people are asked in surveys if they are willing to pay, they will say yes, but then when they have experienced it, sometimes they are less positive. So I think it depends a lot on how long the ride is and the quality of the ride. Where we are at now with the solutions that we have seen so far, it's I think it would scare people off to pay for a ride of this quality and speed.
Okay, thank you for your answer. So there's a question here from our audience. For the shuttle automation demonstration in Linköping, how does the user acceptance look like? Is there any survey statistics data?
Yes, we have done a couple of studies. We have had we just had about our 10,000 passenger, and we have made surveys among the riders, and also try to get to people in the surroundings, because I think sometimes we get the impression that those who are not riding are more concerned than those who are riding. But I think the feedback is that it's a bit too slow. It's nice when it's raining. I would do this instead of walking or instead of taking the bike. Some people who find this very helpful are those who may be on crutches temporarily, or who have a problem, or who carry something. And in general, those who have tried are quite positive. Maybe not for replacing cars, but to try it out or to ride from time to time. But they also think that it's a bit it's a bit too premature yet, and it's not totally comfortable. And yeah, I would say it's a mixed feeling. I think we have to work much more on the total concept, and to make it a bit more, well, we have to get the speed up first, because they are so slow compared to a normal bus. People think, even in all fairness, European cities don't have a very fast traffic through the cities anyway, but sort of you expect these to be a bit faster, I think. So I don't know if I answered well, but yes, we have done surveys, and also we have had surveys with people with special needs, like surveys with blind people, to let them understand if this could be something useful. And in general, they again are quite positive, but also a bit confused with some features that need to be further elaborated.
Okay, thank you. So so that's the question. So I think this is the last one. So great is the question from the Floridi. Great presentation, Ingrid, in respect to the diversity aspect. To be a little provocative, for you think can CCAM help in achieving a non-discriminatory public transport? Today, we still assist to be discrimination in public transport. So I think this is probably about the equity. So
yes, I would think so. I think what was one very important thing that was mentioned in the previous presentation was this the safety and security aspect in transit. And I think that needs to be well thought through to really arrive at equity. Just remove, if we think that we remove a driver, we have to ensure that we have some kind of mechanism for securing well, to get the security level at the right get security at the right level in the bus for every rider, which is tricky, because you don't want to have a big brother watches you mentality either. So I think this is a challenging thing. And having said that, then I think some kind of human being even on automated vehicles may actually need to be there in some role. So yes, I think the potential is there, but it's not just automation that will do that. We have to figure out how we solve the whole service, including the security aspect, to provide equity.
okay, great, thank you. I think a case comment. So I don't think we have time to let the graded to answer, but let me read the case comment. So we have a great funded pilot to use the automated shuttles to connect customers at the nearby bus stop to the veterans admin hospital in our county. Yeah, I believe this is the VTA bus shuttle service using the automated shuttle. Yeah, okay, great. Thank you, Ingrid, for your presentation.
Thank
And
you.
if any audience have any question, please contact Ingrid directly. Thank you. And so let's continue the next presentation by the KC, Emoto, and Lani Ni Ho from the Santa Clara VTA. Well, actually, they are my colleagues. It's great to invite them to give this presentation. And so before the presentation, let me introduce the KC and the Lani. So KC is the Chief Engineering and Program Delivery Officer at the VTA, responsible for the delivery of engineering, construction, and the programs, such as the environmental and the sustainability programs. KC has over 30 years of experience delivering a wide range of mobility solutions. He is a member of the Transportation Research Board, TRB Major Land Committee. He also is the former Major Land Committee Chair. And he has been the member of National Academic Research Panel on Major Lands, Safety Performance, Transformational Technologies, and Land Use. Before VTA, Casey was a transportation engineer in a private sector born and raised in Alaska. Casey has a degree from the University of Alaska at Fairbanks and UC Berkeley, and he is a registered civil engineer in California and Alaska. And we also have another speaker, Lani Li Ho. Lani is a senior environmental planner at Santa Clara VTA. She is responsible for evaluating environmental impacts of proposed projects to the California Environmental Quality Act and the National Environmental Policy Act, and managing initiatives to promote environmental sustainability. Lani approaches project management holistically and collaboratively, with a focus on building and maintaining strong professional relationships with public agencies to get the job done. She is the member of California Bar and holds degree from Santa Clara University. Well, actually, Lani has a JD degree, and the bachelor from the University of California, Berkeley. She enjoys the gardening, dancing, and the camping with her 2 children. Well, thank you, Casey and Lani, to accept the invitation to give a presentation today. So Casey and Lani, that's your turn. Thank you.
Thank you, Peter, for that warm welcome. And we're going to tag team, but I'm going to cut my opening remarks shorter because I know we're running short on time here, and I'm going to reserve time for maybe about 30 seconds at the end after Lani speaks. She's the main speaker. But when we looked into this after you reached out to us, Peter, we saw that on the website, 4 words that caught my attention: zero cost, zero carbon. And so that's what we're going to kind of focus on our presentation, even though the Go-Away's presentation and the transit challenges, and you had that one graphic that showed like 8 or 9 or 10 challenges. As a transit agency, we can relate to all of those. So just to let you know where we are, we're in California in the San Francisco Bay Area. That's what this map shows. We're kind of at the southern end. San Francisco's there's a red dark area that's San Francisco, and you follow that down. San Jose and Santa Clara County are south of there. So next slide. And also as VTA, we're known to be a transit operator, but we do so many more other things. Capital projects that I mentioned or that Peter mentioned, also highway improvements. We do, planning of highway system improvements from planning all the way through construction. We're a regional regional agency that deals with land use decisions and transportation decisions and so on. So that's kind of the background on VTA, and I'll kick it over to Lani to get into the discussion on sustainability and climate actions that we're taking.
Thank you, Casey. Thank you, Peter. All right, so VTA's sustainability program was established back in 2008 with the purpose of conserving resources and greening our internal operations. We have sustainability metrics that we track and report on annually. Those are very important to us. And in response to the climate crisis, BTA's board of directors formally declared a climate emergency and recognized an urgent need to reduce GHG emissions and prepare for climate change. So that's what I'm going to be talking about today. If you have questions or interested in our sustainability metrics, it's a whole separate presentation, but I wanted to talk about more externally how we're reducing emissions and preparing for climate change. But first, I want to go over a couple of key terms with all of you. So when I talk about GHG, I'm speaking about greenhouse gas emissions that are generated from human activities, primarily driving. When I talk about mitigation, I'm referring to reducing the amount of GHG emissions that are in the atmosphere right now. And adaptation refers to the changing climate that is already occurring, what we're already experiencing with the impacts. This brings us to our CAP, or our Climate Action and Adaptation Plan. This grant-funded project kicked off last year and will be complete in early 2024. I have the pleasure of being the project manager of this project, and its purpose is twofold. The first purpose is to minimize BTA's contributions to climate change by reducing GHG emissions. And so that is shown in the mitigation side of this Venn diagram. Our second purpose is to build adaptive capacity and resilience to climate impacts. What's really important is that we must do both mitigation and adaptation at the same time. And I think that's what's really unique to our CAP, because a lot of climate action plans out there, they either do one or the other. They either just look at mitigation, how can we reduce GHG emissions, or they look at adaptation, how can we address climate change impacts? And I think both are equally important, and we have to do them at the same time because climate change is already here, so we have to adapt. But we also have to reduce GHG emissions at the very same time so that it doesn't get worse. Specifically, our objectives are to identify measures to reduce GHG emissions, as I mentioned, and then to quantify countywide GHG emissions related to transportation and identify actions to reduce vehicle miles traveled, which lead to GHG emissions. And then lastly, to conduct a vulnerability assessment of BTA's transportation assets. So our first task was to prepare an inventory of emissions of surface transportation uses in Santa Clara County. That inventory that we did, the finding from that was that the surface transportation sector in our county generated over 4 million metric tons of carbon dioxide equivalent emissions in 2019. We chose 2019 as a pre-pandemic year. And the surface transportation, that sector includes both on-road transportation as well as rail transportation. And the on-road transportation sources or modes are shown there, and so it's broken down on this slide. But the drive alone trips are definitely the largest source of GHG emissions that we found in Santa Clara County. So no surprises there. And then we also did an inventory of BTA's own operations. And what we found was our revenue and non-revenue fleet, which is shown in the blue and orange line bars, they produce 22,200 metric tons of CO2 equivalent emissions in 2021, which account for about 80% of BTA's total transit operation emissions. So it's really our fleet that makes up the majority of our emissions. In case you can't see the other bars, if it's hard to read, if you follow me in the legend on the right, the top is water, followed by employee commute, waste, facility energy, non-revenue fleet, and revenue fleet. So like I said, again, the orange and blue, the fleet, both non-revenue and revenue, make up the majority of our emissions. So then the next task that we worked on was identifying the GHG emission reduction measures that we could take. And so the measures to reduce GHG emissions and vehicle miles traveled were identified and grouped into 4 main focus areas shown here: transportation and land use, buildings and facilities, fleet and employee commute, and materials and waste. We applied criteria and prioritization was given to measures with the highest GHG reduction potential. We quantified as many measures as we could, and the sum of all quantifiable measures would result in a savings of over 14,000 metric tons of CO2 emissions per year, which is approximately equal to the removal of 3,634 gas-powered cars from the road. And in case you're curious of the methodology we used, I wanted to let you know about this wonderful resource. So the quantification is based on formulas from this handbook, which has a very long name, but it's known as the CAPCOA handbook, and CAPCOA stands for California Air Pollution Control Officers Association. And it was also developed with input from Fair and Pierce. And so this is really the key resource in California and known and referenced by many, many practitioners as the leading source for developing mitigation measures for both VMT and GHG emissions, if you wanted to look that up. So the next task that we did was assess our vulnerability to climate. And we did these Miro board, virtual bulletin board exercises with considering input from staff. A lot of community outreach went into this effort, and the evaluation includes how coastal flooding, which is sea level rise, inland flooding, which is urban riverine flooding, wildfire, extreme heat, and drought will affect BTA facilities and operations. Out of all of those hazards, I'd say that extreme heat and flooding are our biggest threats for BTA. I'll share some maps in a minute to give you a sense of how vulnerable we are to flooding. Extreme heat cannot be mapped, so I'm going to just talk about that. And we know that the rise in temperature and frequency of extreme heat events will have significant consequences for multiple aspects of BTA's assets and operations. This could include buckling of light rail tracks, slowed service speeds, overheating of substations, signal houses, and IT equipment, and also unsafe conditions for BTA workers and riders. In addition, heat can lead to power outages, which can make it difficult for battery electric buses to charge and have cascading impacts throughout BTA's service area, as our light rail, transit centers, and other facilities depend on electricity. And not all aspects of BTA has backup power sources. So those are some of the impacts to extreme heat. Here is some of the mapping we did of flooding, which is, you can see here that on the, the left side of the screen is coastal flooding. And so for sea level rise, the assessment evaluated permanent coastal inundation. This is due to permanent sea level rise and temporary coastal flooding from sea level rise, coupled with an annual chance of storm surge. And it focused on the 2050 time horizon. And so the average daily boardings of our system are shown in the purple dots here. On the right side of the system is right side of the screen is a map of the evaluation of assets exposed to creek and riverine flooding, so inland flooding. And this is from a 100-year and 500-year storm event. And so we were able to assess how flooding could lead to asset damage, loss of access to facilities and routes, which could cause transit delays and loss of service, and the need to relocate structures if they are permanently inundated. We know that flooding can also submerge substations, which could lead to loss of power and cause cascading impacts for the system. So this is our temporary flooding impacts to bus routes and stops. The next slide is temporary flooding impacts to light rail routes and infrastructure. Again, there's the coastal flooding shown on one side of the screen, and then the inland flooding on the other side, with average boardings shown in purple. And so we know that extreme rain can lead to flooding on city streets by overwhelming the storm drain system and river channels, and that assets can be damaged during flood events, and access may be limited until these floodwaters recede. The reliability of VTA operations is often impacted during flood events, and even in the absence of flooding, heavy rains can impede transit operations, especially when there's strong winds. Impacts from extreme rain will worsen with climate change, so understanding the potential increase in heavy rainfall will be critical in building flood resilience across VTA's system. These pictures here are real pictures from actually just this past January. I don't know if you've heard about the atmospheric rivers that hit California, Northern California specifically, a couple months ago. But this is part of our highway system in South County. I believe this is Highway 101 and State Route 25 interchange that is completely inundated. And also shown here is a bike trail that you can't even access anymore. So these are real impacts. We're not talking about something that's occurring way far in the future, right? This is what we're experiencing right now. After we assessed the vulnerability and completed these maps, we prepared a list of adaptation strategies and potential actions. So there's actually a total of 14 adaptation strategies with 64 potential actions that we can take. I only listed a handful on this screen. A lot of it is how can we install backup power or integrate climate adaptation considerations into our design standards and criteria and guidelines. Implement cooling features to prepare for extreme heat events to help both our staff and riders cope with higher temperatures. So there's a lot of actions that we can take. And as part of our next steps, we'll be further looking into how we can implement these. So speaking of next steps, this is a quick project timeline. As I mentioned, the project launched last year. We're currently in the technical analysis phase, shown in green. A draft of our CAP is expected in a couple months in fall of this year. And then we will take a final CAP to our board of directors in early 2024. And so I have no idea if I'm on time or not. I cannot see Peter and I cannot see the chat, but that's the end of my presentation. So I'll take any questions and stop sharing.
Well, thank you, Casey and Lani's presentation. What I learned from here is innovation. Our topic is innovation in transit. Innovation is not just the technology innovation. Innovation also including the innovation in methodology, the innovative procedure, how to increase the sustainability, reduces greenhouse gas emission, and also increase equity and so on, and avoid, as what I saw the picture, avoid some natural disasters. And yeah, so I think that the innovation just including both technology and the methodology. So I want to know if any audience have any questions about Casey and Lani's presentation. Oh, okay. So from the QA chat here, I saw a question from Xu Mei. So her question is a wonderful presentation from Casey and Lani. Except for the greenhouse gas emission evaluation at the VTA, are there other air pollutant evaluation from transit systems such as PM. One
Yes.
of initiative for greenhouse gas emission alleviation is bus electrification. What is the diesel bus replacement plan for the VTA in the future?
Yeah, let me start about the air pollution evaluation, and then Casey can follow up with our zero emission bus plan, a little bit about that. So yes, absolutely. In addition to GHG emissions, we also evaluate and track our criteria air pollutant emissions. And that's part of the sustainability metrics that I mentioned kind of at the beginning that we track annually. VTA's air pollutant emissions have been trending down. I think our reduction is around 88% since our baseline, because our vehicles are getting cleaner. And so, yes, air quality is extremely important to us. It's separate from climate change and GHG emissions, but definitely a sustainability metric that we are tracking because it does have public health impacts. As we transition our bus fleet to zero emission by 2040, it will definitely get cleaner and also have the dual effect of not only cleaner air, but lower GHG emissions.
Yeah, and in terms of specific steps we're taking, our next shipment of buses would be battery electric buses. And then the one after that could be battery electric or hydrogen based. So we're going through those evaluations. And so, as Lonnie mentioned, we have to get to zero emission fleet by 2040. That's a regulation or regulation adopted by the California Air Resources Board. Specifically, I think it's called the Innovative Clean Transit Regulation or something like that, ICT. So that's what we're all following here in California. And so there's a big push towards trying to get to a non-diesel, electric or hydrogen type transit fleet. So all the transit operators in California are working on that. So
yes, that's right. And under the there are zero emission vehicle mandates, and this is under the Advanced Clean Cars regulation. So all transit agencies are required to move to zero emission buses, but also it affects passenger vehicles as well.
Okay, great, thank you. I think I think this is the last question for Casey and Lonnie. Related to air quality and clean cars, are there any measures being taken to reduce tire wear, which is a contribution to PM 2.5 and microplastics, aside from fuel gas emissions?
Yeah, I can answer that one as well. So this really is about reducing vehicle trips and reducing VMT. So by avoiding and reducing vehicle trips and VMT, that's where we're really going to reduce harmful air pollution generated from fossil fuel combustion and braking and tire wear across all vehicle types, which does have impacts to public health. So reducing vehicle trips and VMT by expanding transportation choices and offering more sustainable land use patterns, that will help reduce the automotive dependency that we have and the long commutes associated with urban sprawl, and really does improve the overall quality of life. That's why it's not just important to reduce and focus on GHG emissions, but also reducing VMT, which in Santa Clara County is projected to increase by 2050. So with population growth and everything else, VMT is expected to go up by about 25% from 2019 to 2050. And so person asking this question is right on the money in terms of reducing tire wear and everything else that's associated with driving a car. Let's just reduce having cars in the first place.
Okay,
and
great.
another way we're tackling that is that we have several transit centers. We have light rail station areas that where we're building TOD, transit-oriented developments, so that it makes, the for people to be able to take transit more easily. And so that's another way that we're tackling it. And so as a regional operator, we're able to work with the cities and do some of the things that Lonnie's talking about, looking at VMT and those sort of things. And we have a program that's tracking these sort of measures, right? Our transportation system management program is tracking various measures. I think they've been doing this for about the last 8 to 10 years or something like that. So yeah, there's many different ways that we're doing this, and it's keeps us very busy.
Okay, thank you, Casey and Lonnie's presentation. Yeah, because of time, we have about 15 minutes late because due to the Zoom link issue. So I think because this is the last session for today, so I think we are okay to extend. So our last presentation still have about like 20 minutes and 10 minutes discussion. So we may extend this session to 15 minutes more. So you are welcome to stay and to continue to support our session. So thank you, Casey and Nani. Thank you. And so Kostas, could you share your screen? And let me introduce our last speaker, Dr. Konstantinos Gkiotsalitis. So Kostas is an assistant professor in public transport at the National Technical University of Athens. Well, I want to express my appreciation to the Kostas. Yeah, because in Athens now it's almost 11 p.m. So I appreciate that you still stay until very late in your time zone. Thank you very much. From 2012 until 2018, he was a research scientist at the NEC Laboratory, Europe in Germany. And from 2018 until 2022, he was an assistant professor at the University of Twente, Netherlands. He is a member of ECTRI and the URTP. He serves as editor at the Transportation Research Record Journal. And he is also the paper review coordinator of TRB Transit Management and the Performance Committee, AP010. He is the author of the book Public Transport Optimization, Spring Nature, and has co-authored more than 50 publications to peer-reviewed scientific journals. Thank you, Kostas, with us so late. And now your turn for your presentation. Thank you.
Thank you, Peter, for this very kind introduction. I would like to thank the organization committee for this kind invitation. I hope you can all hear me. As you said, it's a bit late in my time zone. This is why the lighting also is not perfect. If there are any, because I'm also at the same time, this is a vacation period here. If there are any issues with the internet, please let me know. I hope not. So far, it worked very nicely. And I would also like to say it was very interesting for me to see the presentations on, because I'm working many years in public transport, all the presentations starting from FTA in automation and continuing from Electron connected and autonomous vehicles down to electrification and the challenges we are facing. We are all in public transport. These are actually main issues we are all facing now, and the presentations are really spot on. I would like to take a bit of your attention to another issue. Automation, electrification are very important topics in terms of research, and they're on the very front of the research activities from the industry and universities. Another aspect that is also getting more traction year after year is the mobility hub, or in plural, mobility hubs. And I will discuss today about what is the status, more or less, in Europe, European project we had on mobility hubs, and the scheduling integration challenges ahead for integrating public transport and shared modes, shared mobility at specific places in cities. To give you an outline, I will briefly discuss about what is a mobility hub. When it all started, the discussion about mobility hubs, their main characteristics, some examples of mobility hubs from Europe, the categorization issues we are having when we try to define the mobility hubs in more detail, and what we try to do in terms of research. We have developed from a project called Smart Hubs. We developed 3 ladders, actually. We will discuss about them later on to give something concrete and possibly objective to anyone who wishes to categorize a mobility hub in its own city or in its specific locality. Then I will discuss about planning and scheduling issues, and this will close for mobility transport modes in mobility hubs, and this will close my presentation. We start with what is a mobility hub. Possibly you've all heard about this term. It has been around for quite some time. Some years before mobility hubs, we had mobility as a service. From mobility as a service, which was also kind of a movement in urban transportation. Now from mobility as a service is still getting a lot of traction, but we also have over the last years mobility hubs, mainly stemmed from the rapid increase of micromobility in our cities. To give definition, a proper definition, there are some research papers that are trying to define what is a mobility hub. There are many definitions, actually. I chose to present a recent one, which states that a mobility hub is actually a physical location. It exists in the real world. It's not a digital twin or something else. It has existence in our cities, where different shared transport options are offered at a dedicated place, which is non-temporary. It exists there, and there is some stability. It is recognizable. There is a specific location. Maybe there are also markings on the pavement, and also there is information about it. You might even have payment systems in mobility hubs. And typically public transport is available within walking distance. This is one of the definitions used. There is a lot of debate, of course. In some cases, we might have mobility hubs which are defined without public transport. There are, for instance, only shared cars and shared bikes in neighborhoods. And this concept, I give also a quote from Lydia Signoris, UITP Combined Mobility Manager, stating that mobility hubs provide cities with a powerful tool to efficiently reorganize space for people and not for private cars. These hubs pave the way for the 21st century low-carbon multimodal mobility. The main objective is with the mobility hubs to provide a realistic alternative to owning a car. And I can give you an example. In the Netherlands, we had in some neighborhoods where there were developments, construction of new houses in some neighborhoods. Instead of providing parking spaces, it's a regulation every house to have a parking spot. Instead of providing parking spaces, the builder of these houses provided the infrastructure for mobility hubs, which included shared cars and shared bikes and e-scooters, trying actually to replace the need of owning a private vehicle. This is the main drive behind this movement and this change of the use of our infrastructure in the cities. when it all started, actually, mobility hubs are a new idea. After 2000, we heard about them for the very first time, but already from the 70s, you might have known the notion of park and ride. Typical examples at metro stations, especially at the outskirts of cities where we have a lot of space. Many times the travelers can park their vehicle, take the metro or the train and continue their journey. This is kind of a primitive version of a mobility hub, if you wish. And the core idea is the physical, the spatial connection between multiple transport modes at a specific spot where travelers can switch between modes. Why we discuss about it? If park and ride was already known from the 70s, why this area has gotten a lot of traction is because apart from private cars and trains, we have a very sudden increase in the shared mobility services in cities. In Europe, for instance, we have regulations by 2050 to be CO2 neutral, and there are 100 mission cities that are requested to achieve this goal by 2030, in pretty much 7 years from now. This has pushed them a lot, has pushed cities a lot to, among others, because the transport sector is roughly responsible of 30 to 35% of the entirety of emissions. This has pushed cities a lot to offer such solutions. And there are many pilots in Europe and many European projects around this concept. Of course, as it was also mentioned in other presentations, which were actually spot on, automation, electrification is also a research topic that can also help us with the goal of achieving climate neutrality. Now, the main characteristics of mobility hubs, there are many studies discussing about them and what different authors and in many cases these studies have performed surveys and semi-structured interviews with experts. It seems like a mobility hub in 95 of the cases refers to a location where we have multiple modes passing from that location, from that place. And in 89% of the cases, at this location, we have transfer between modes. This was also happening back in the days with park and ride. Because also shared mobility is increasing a lot. Now, slowly, shared mobility is also intertwined somehow with the idea of mobility hubs in the minds of travelers. And in 54% of the cases, a mobility hub is seen as a place where we have shared mobility options, and 49% as a place where we also have at this location public transport modes that have, for instance, there's a train station or a bus stop in the surroundings of a mobility hub. The lessons we have from past studies from literature on mobility hubs are twofold, I would say. There is a bit of a disagreement of whether we really need a location to have a public transport stop to call it a mobility hub, or if we really need to have shared modes. And this is debatable. What is not debatable, and it's kind of a final verdict, is if we have a location with a public transport stop or several stops, and we also have shared modes, this can be seen, definitely it can be seen as a mobility hub. And I will show you some examples from Europe, of mobility hubs from Europe, to get an idea. We have a first example in Vienna. You see here we have markings on the pavement indicating that we have shared e-scooters. And here we have also bike sharing and cargo bike sharing at this specific location. On the other side of the street, there is also a pillar where someone can pay for the service. In the second picture from Brescia in Italy, we have bus, train, car sharing, bike sharing, and taxi. And particularly, it's actually the city center of the city. In Antwerp, in Belgium, you see the pillar here. We have bus, tram, and bike sharing. And in the UK, there's a picture with bus, car sharing, and bike sharing. It's not like we try to handpick these 4 areas. Actually, there are hundreds of mobility hubs defined one way or another in Europe at this point. And for this reason, there are categorization issues. They are not all mobility hubs equal, if you wish. And in other words, they are not all the same. We have locations with a huge volume of trips. I can give you an example. The Utrecht Central Station, it has at least 2 underground floors with shared bikes. And there are also buses passing by the station. There are also shared cars. It's a huge hub, and there are also other locations to go to another extreme. The example I gave before with neighborhoods in the Netherlands, where we only have shared cars and shared bikes. And because this term is used interchangeably, the term mobility hubs, something we try to do in a research project was to try to kind of categorize these mobility hubs and let others, more importantly, to categorize mobility hubs in their specific localities. Taking many aspects into consideration, first is the trip volume on the hub. If it's a major hub or a hub with few trips during the day, the physical connection of modes, are they all at the same kind of location, or a traveler needs to walk a lot? The markings that make a mobility hub visible, if it is clear for someone that all these modes are in a very close distance because they form a mobility hub. The payment system and the payment integration, which means someone can buy a ticket, for instance, for public transport, and also use it for bike sharing or using an e-scooter and so on. And the inclusive design, which has to do with how these mobility hubs were developed. We had the problem with mobility as a service and mobility hubs, at least in Europe, probably also in other locations, that many of these activities, mobility as a service schemes, for instance, they were top-down. A company was starting a mobility as a service without really understanding the needs of the citizens. And in many cases, these initiatives failed. The same holds for mobility hubs. This is why we have 3 dimensions. One is the physical integration of the mobility hub, which means if we really have many services, many transport services together at a specific location, the travelers can transfer between them. The second aspect is the digital integration in terms of information exchange and also ticketing. And the third one is, if you wish, a democratic integration, which is it refers more on the inclusive design. If citizens were asked about the development of mobility hubs and if they were involved in co-creation activities. From this, we have made a ladder. This looks a bit overwhelming at first, but we actually have these 3 different integration areas: the physical, the digital, and the democratic. And we have 5 steps in the ladder, starting from 0 to 4. If we go up, a mobility hub it gets a better score. It becomes a smart mobility hub, if you wish. And at the bottom, of course, we have, in the 0 case, there is a single mobility service. We don't talk about mobility hubs. There's no physical integration, no digital integration, and no stakeholder involvement. As we are going up, things are improving. We have walking distance between shared modes and public transport. We have some sort of digital integration. And if we go all the way up, we are reaching full integration at all levels. We might have many modes at a very close distance. We have integration of policies and universal design principles. We have ticketing integration. From the democratic perspective, we have social learning. And kind of something to remember is a mobility hub might score very well in one of the three pillars, if you wish. For instance, might be very well integrated, like I referred before to the train station in Utrecht, but it might not have a very good democratic integration in the sense that stakeholders and citizens were not involved. And in terms of ticketing and payment, you might need to buy different tickets for shared bikes, trains, and buses. This, however, gives us kind of a roadmap on how to categorize mobility hubs. And we have developed an open data platform. You see this a screenshot from Europe. This is a project of roughly 2 years. We've done a lot of things in these 2 years trying to categorize the mobility hubs in Europe, because we know it's not possible to do it on our own. We are a consortium with a limited number of partners, of course. What we have done, we developed this open data platform, and we also give this the guidelines for the integration ladder of mobility hubs, and we are asking actually researchers, industry, municipalities to go to this platform. It's available online. I also put the link here. It's open access. Everyone can add a mobility hub in the associated locality. Pictures can also be added of the mobility hub, and I will show you an example. And we're very happy to have 154 mobility hubs in a very short time. And all of them are categorized. We can make in the future. It's not only useful to make comparisons, but also for local policy makers. They can understand their weak points. For instance, they might have very bad digital integration or democratic integration, and try to work on these points. This is the project I referred to before, the smart hubs, and you see a list of partners. I will not spend a lot of time here, but as I said, everyone can add information about mobility hubs in an area close to his home or her home or office. I will give you an example now from this platform and the categorization. You see in Vienna, you see the place, the picture I showed before. Someone has added this picture, for instance, showing the hub, and there are different aspects someone can include. First is typology, and then if it's a large hub or a small hub. And then is the status, if it is ongoing, if it has not started yet, if it was ongoing but now stopped, and so on, with some information about it, when every service was launched, the start year, when in this case is 2021, and this continues. We have OpenStreetMaps where you can really put a pin there and demonstrate the location of the hub. And then we go to the integration levels for each one, starting from the physical integration. The person who is adding this information can judge from the integration ladders and put it in a level and explain why. Then after that, there is, of course, mediation of this information. Is not going online immediately. We also check for consistency and make a comparison before uploading this information. And the same holds for digital integration and democratic integration as well. Lastly, one can also add which services are provided at the mobility hub. You see here, we have buses, car sharing, bike sharing, and cargo bike sharing, and also other mobility-related services, which are not really, we don't talk about transport modes, but we talk about supporting services. To give a full picture of the hub, we have 154 as of today, and we aim to get more information in the future. These are not all the problems with mobility hubs. It's not the physical, the digital, and the democratic integration are big issues, but there is also another layer altogether, which does not have to do with the location so much, but it has to do with the synchronization between services, the planning and scheduling aspect. There are several problems on that. First is that the system is very fragmented. Public transport operators, probably they use some software to create the timetables of their lines and the vehicle schedules and the crew schedules and so on. And typically this is done in isolation. Public transport operators, they want, of course, to serve, to increase ridership, serve as many passengers as possible, and not have reasonable waiting times for passengers and reduce their operational costs, both in terms of drivers and vehicles. There's not so much thought about synchronizing their timetables with shared modes, for instance, or flexible modes. The same applies for shared modes. On the other side, there are many questions at the beginning for fleet management, where to put shared modes, to which locations, if it's required to put shared modes in mobility hubs, and what type of modes. Will there be bikes? Will there be scooters or shared cars? And there is also the big problem of rebalancing. We see it many times. In the Netherlands was common in some stations, for instance, some train stations during peak hours. Many passengers are exiting from the train at the same time, and there are not enough bikes for everyone, which is very frustrating because it defeats the purpose of having a mobility hub and reducing the door-to-door travel time of travelers. These travelers will get frustrated and maybe will go back to owning a private vehicle eventually, if the system is not reliable. And there's, of course, passenger crowdedness that can result in safety issues during peak hours at mobility hubs. We have done some effort also in this direction to try, I won't go because this is more mathematical, if you wish. We don't have time for that. We have done some effort on trying to synchronize the schedules of collector and feeder lines, or if you wish, more flexible lines operated by minibuses or shared vehicles, to reduce the waiting times of passengers at transfer points and improve their schedules. There are also works on rebalancing, trying to put shared bikes, scooters, and so on to the locations of the highest demand during peak hours to avoid this problem of having not being able to continue with the last mile leg of the trip for a passenger. And this is, I will close with kind of a roadmap. What we see, right now, we started with park and ride from the 70s. There were some first discussions pointing to the direction of mobility as a service in 1966. Of course, it took a lot more time to concretize this idea. From 2003, there were also again some initial discussions about the first terms of mobility hubs appeared. 2020 started more of a serious effort to categorize mobility hubs because the term is used for many different reasons, and sometimes we cannot understand on what we are talking about. And in future, we can move, our plan is to move, and generally I think it's important to move from a well-integrated mobility hub in terms of physical and digital and democratic integration to mobility hubs that have also synchronized operations between their modes, both for public transport and for shared modes. That's all from our side. These are some contact details. The book I said before, it has some information of scheduling, integration aspect, and I've also put some information if you wish to contact me. And I would like to thank you and thank all presenters for the very nice session we had this evening from my side.
Well, thank you, Kostas, for your presentation. Now we have one question here. So, okay, let me see. Yeah, my eye is not clear. Great presentation from Kostas. How the trip demand for mobility hub can be estimated, and what factors should be considered for the location of modern mobility hub? Can the service from smart hubs be paid at one-click platform?
This is a very interesting question. Actually, I will try to decouple these questions. The first is how the trip demand for a mobility hub is estimated. Typically, because we have a travel chain, these are estimated from traditional origin destination surveys we are having at the municipality level. Of course, information from public transport operators helps a lot because it updates pretty much. We can have updates every day. But because we want to know what happens outside the public transport system, travel surveys help a lot in this direction. The second aspect, what factors should be considered for the location of modern mobility hubs? Of course, as you saw, it is very important to have mobility hubs close to the locations of public transport, in the sense that in most reviews, in most surveys with travelers, one of the main problems of public transport is the first and last mile of a traveler. And this is why if we want, let's say, to achieve more with the money we spend with mobility hubs, it's prudent to try to integrate, to use them close to public transport stops and integrate shared modes with public transport services. And the last one, if the service can be paid for one-click platform, there are some pillars. I saw some pictures where you can pay in future. Ideally, and this is the kind of the goal, and this is actually the goal of mobility. This was the goal of mobility as a service, which is still in place, to be able to pay within a city, to pay a single ticket or a fee and have access to different services. There were some business models in the past in European projects where a family was paying a monthly amount, like I will give like something like 300-400 euros, and with that they had the promise they can access every shared mode and public transport service in their city. So I would say it depends, of course, from location to location, but this is the direction actually in terms of payment integration.
Well, thank you. So actually, I personally have a question. So your last slide show the roadmap and show the maps. So could you please clarify the difference or the main difference between the mass and the mobility hub?
Yes, sorry, I went back to the slide. I thought there would be
Yeah.
you would like you to share. Mobility as a service is a more general concept and has to do with payment primarily. The example I gave with you pay a specific amount of money, for instance, a business model might be you pay a specific amount of money and you have access to multiple services. This does not necessarily mean that there are mobility hubs in the city. Maybe you have access to shared cars close to your neighborhood and public transport at the city center and so on. The difference of mobility hub is it's something at specific location, specific place where multiple modes are passing from this area. Does not have to do with offering a business model where you pay one time and you can use everything in the city. It is more, it's something more location-based with that has also physical characteristics. It has markings, it has information, and so on.
Okay.
It has infrastructure, let's say, actual physical infrastructure.
Well, thank you. I think we probably well, okay. So this a comment. I don't know if it's a question. So from the Florida, many thanks, Kostas, for your very clear and inspiring presentation about estimate the effects of these mobility hubs on the reduction of carbon dioxide emission by building block, for example.
Yes, very good question. Thank you, Florida. You also stayed late. We're in a similar, almost similar time zone. These operations, they're very complicated. For smaller cases, we had projects in neighborhoods in the Netherlands, and this was possible to estimate based on the trips of citizens that were not buying private vehicles. They had a mobility hub in their neighborhood, and this was part of the agreement with the construction company. Because this at lower level, it's more easy to measure. In other places, like in Rotterdam, in Leeuwenburg, it's a central station. It requires kind of. It is not so easy to make this comparison. To do it, it should be a before and after analysis, meaning that we measure the situation before, how many cars were in the streets of a particular area, and if this number of vehicles reduced after some time when we implemented a mobility hub, because the travelers can come and go from different parts of the city. Whereas in a neighborhood, we really know how many citizens are living, how many households we have, and it's easier to make this calculation.
Okay. Well, thank you very much, Kostas. Yeah, I think your time is really late, so I appreciate you stay with us until now. And yeah, actually, I know the Kostas for almost a decade, and he's an excellent author. Yeah, he presented a podium presentation in my committee, Bus Transit Sales Committee, for many times. And he also is a great reviewer, and he can review any paper, any analytical paper, which is not always accepted by some reviewers. So I appreciate it, Costa. Thank you.
Thank you, Peter.
And so,
in public transport, in public transport. Thank you, Peter, for
Okay.
this for the very nice organization of the special session. And hope to see you, all of you, probably many of you actually. We might see each other again.
Yeah,
in
definitely.
soon.
Well, I just see to the comments. Let me just read I think Costas probably is really late. So I just read this comment. So one from Casey in Europe, what are the most common sources of funds for mobility hubs? Private fund is net positive revenue a goal? And the other comments from the Floridi. Many thanks, Costas, for your very clear and inspiring presentation about the mobility hubs. Could you be able to? Oh, I think I just read that. Okay, sorry. Thank you for the informative presentation from my side time.